Hello, I'm David Noel. Welcome to episode 03 of SMB. The topic today is fusion energy, that is, getting energy from fusing atoms together. Earth's main source of energy is the Sun. In the Sun and in most ordinary stars, energy is produced by fusing atoms or parts of atoms together. The amount of energy you can get from atoms depends on how tightly their components are bound together, their so-called binding energy. The graphic shows how this binding energy varies with the total mass of the nucleus of different atoms, their mass number on the bottom scale. The mass number is the total number of protons and neutrons in an atomic nucleus. In any atom, the number of protons in its nucleus determines what sort of atom it is. For example, any atom holding 26 protons in its nucleus is an iron atom, symbol Fe. The simplest atom is hydrogen, which has just one proton in its nucleus and no neutrons. Fusion in stars starts off by fusing hydrogen into helium and then fusing the products into heavier and heavier elements, such as carbon, nitrogen, and oxygen. The red line on the graphic shows the binding energy of different atoms. Hydrogen and helium, with low mass numbers, have low binding energies. Fusing them into heavy atoms releases a lot of energy. One of the biggest research efforts of the last 70 or so years has been to produce controlled fusion energy on Earth. In theory, it will provide plentiful and cheap energy for mankind's use. We have produced this so-called thermonuclear energy on Earth, but not in a controlled way, only in hydrogen bombs. It's very unfortunate that research on controlled fusion energy started off with a fundamental mistake. As a result, it has got nowhere. In a way, the term thermonuclear is the wrong way round. It suggests that putting heat, thermo, or energy into a nucleus will give out energy. A fussy person might suggest that the term should be nucleothermal, that is, work on a nucleus and it may give you thermal or other energy. That's the reality of the situation. So we'll look now at some of the reasons why it should have been spotted that controlled fusion needs application of pressure, not high temperatures. The first reason to suspect the current work on controlled fusion that it has been going on now for more than 60 years and has been totally unsuccessful. This is in the sense that none of the elaborate and expensive machines built have ever produced more energy than was used to run them. It should have occurred to someone in the research field that they must be barking up the wrong tree. Here we have identified this mistake, that all current approaches have tried to inject energy and raise the temperature of reactants, while they should have just used high pressures. The second bit of evidence that the pressure approach must be the valid one is to consider how stars start up. It's not disputed that stars, like all objects in space, form by gathering up material from the surrounding space. When an incipient new star has gathered up enough mass, reaching a threshold of about 7.5% of the mass of our Sun, it can commence what's called ignition. It starts fusing hydrogen. The fusion process in stars gives out energy, and this shows up as radiated light and heat. Stars certainly become very hot, but this heat is the product of the fusion process and not the driver of the reaction. When a potential new star is on the point of ignition, it has accumulated a lot of mass, probably mostly as hydrogen, and its internal ringes will be under immense pressures. It is these pressures which start fusion. High temperatures won't be present until fusion begins. The third evidence point is one of the basic things in modern chemistry and physics, as currently understood. Reactions, whether chemical or nuclear, are either exothermic or endothermic. That is, they either give out excess energy when they occur, or they absorb energy in order to take place. To get net fusion energy, we need an exothermic reaction. It is well established that exothermic reactions are suppressed, are slowed down by putting in energy. So fusion to produce net energy can't happen if a lot of energy needs to be put into a reaction. But applying high pressure can promote a reaction without heat. Reason 3 is a killer point. Research efforts which ignore this point are doomed to failure. Some of the myths identified in the present SMB series acted as blind alleyways in the development of science, but they have not been as enormously costly like the present case. The money wasted on failed fusion approaches has been huge. Not millions of dollars, but thousands of millions of dollars. Maybe enough to run a small country. There's been nothing else like it in human history. Certainly big sums have been wasted in the past on wild goose chases, but nothing on the scale or time span seen here. Now we can summarise the new ground rules for energy production through controlled fusion of atoms. The first ground rule is that successful production of energy through controlled fusion of atoms will need the application of high pressures. The second ground rule is that to get net energy production from a reaction, an exothermic reaction must be chosen. Adding energy from outside to such a reaction suppresses it. It's worth noting that in the instances where nuclear fusion has been achieved by man, in hydrogen bombs, very high pressures were involved. Not always appreciated that in most models of atomic and nuclear bombs, one part of the bomb is fired at the other using conventional explosives like TNT. A very high pressure is achieved, but only momentarily. In closing, here is a link to a referenced article on the web, which gives more detail and links on the current topic. Following that are some links to other sources available to you, both episodes on our YouTube channel and a website including articles which quote established and reference data. Have a look. So it's goodbye from me, David Noel. Keep well.